So, hello. So today we're going to visit Professor Rick Leemans. Rick is professor in environmental system analysis, and he also contributed to this big report of the Intergovernmental Panel on Climate Change. So let's see what he is going to tell us. Hello Rick.
Hi Huub.
Nice to meet you again.
Good to see you.
I would like to ask a few questions about climate change.
That's possible. That's possible. Let's sit down.
Okay. So Rick, climate change, what is that actually?
What kind of climate change are you hinting at? Is this the long-term natural climate change? Climate has been changing throughout the history of the Earth. We have had the ice ages, we had major volcano outbreaks. Climate change is in principle natural. But over the last 150 years, we really see a climate change which is caused by humans. It's caused by our use of energy, our use of different resources. And if you look at energy, the fossil fuels especially, coal, oil, natural gas, we use an enormous amount of those fuels, and if you burn them, they release CO2 into the atmosphere. If you change forest into agricultural land, the forests are burned and that produces CO2 in the atmosphere. If you use cement or produce cement, every ton of cement is a ton of CO2, and that ends up in the atmosphere. And besides CO2, which is the major greenhouse gas, we also have some others, like methane, which comes from cattle, from wetlands, from mining, and N2O, or laughing gas, which very much comes from fertilizer and manure use.
Especially the CO2. I understood that stays very long in the atmosphere.
Yeah. At the moment we emit about 11 gigaton of CO2. That's 10 to the 18th ton of CO2. And that's an enormous amount. About 25% of that amount is taken up by the oceans, and about 20% is taken up by all plants in the world. The rest remains in the atmosphere and contributes to the increase of concentrations of CO2. Now, if we look at the greenhouse gases, CO2 is the most important. It's the most important because it has a high concentration in the atmosphere compared to the other greenhouse gases, and it sits in the atmosphere for more than 1,000 years. So every molecule of CO2 that you don't emit has an impact over a period of 1,000 years. Methane is a much stronger greenhouse gas, but only sits in the atmosphere for about 20 years, and then it's broken down to CO2. N2O, or laughing gas, also has a relatively long period in the atmosphere, 70-80 years, and is a strong greenhouse gas, but the concentration is about 1,000 times lower than that of CO2.
The CO2 concentration in the atmosphere is now 400 ppm. That means one molecule in the air compared to 2,500 other molecules is carbon dioxide.
Yes.
How come that such a little amount is causing such a global effect?
Now these concentrations are very small, but the power of CO2 and the other greenhouse gases is that they absorb heat in the atmosphere and radiate them in all directions. So the heat doesn't escape to space anymore. And that's the radiative forcing of CO2. The concentration is small, and maybe you say, oh, we can ignore it. But if you look at small concentrations, they can definitely have an impact. Think about 3 glasses of beer. If you're sober, you drink 3 glasses of beer, the content of alcohol in your blood is about 400 ppm. And then you're not allowed to drive anymore. Your behavior has changed. So small concentrations do matter.
So our atmosphere is at the moment a little bit drunk. Yeah?
It's at least disturbed and influenced by humans.
Okay. And then, if you look at cities, the urban environment, how is then this climate change has the impact on the urban environment, and how important is that for us?
Now, if we look at climate change, it's getting warmer. A warmer atmosphere holds more water, so you also get more precipitation. And most of that precipitation, if it's getting warmer, we get more thunderstorms, so heavy rain showers. And if we look especially at city environments warm up very, very easily with all the concrete, etc. So a heat wave in a city would be much more severe than, for example, in a forest or in a large park. You can easily see that with Central Park in New York. That's about 5 degrees cooler than the surrounding cities. And the other impact is very much the big storms or the big thunderstorms, which give a lot of rain and lead to local flooding, problems with water, etc. So the sewage canals have to be changed, and if you want to adapt to those impacts.
But I understood there's also another effect, that many cities are located in the delta areas, and there we have the risk of flooding and also the salt water.
Now, one effect of warming the atmosphere is actually that the oceans also warm, and some of the ice on land starts to melt. So sea level rise comes up. And if you have a lot of delta cities, the sea level rise actually threatens the livelihoods of these cities with flooding, but also through more salty water in the rivers. And that salty waters could actually threaten the fresh water, the fresh drinking water, and crops in the cities. And in some areas, delta areas always have enough moisture, and you see that in Egypt. There are very big contrasts between the deserts and the delta. But especially in dry areas it will be drier, and wet areas it will be wetter. And therefore, with climate change, you get problems with flooding, but also with drought. And those droughts immediately affect the amount of water, the available water, drinking water, but also for crops. So indirectly, the amount of crops that the city consumes could actually become a problem.
So in the urban environment, we are confronted with at least 4 different factors.
Climate change is not simple. It is quite complex. The impacts are complex, and you really, if you want to adapt, you have to look at the temperatures. How do we actually forego extreme temperatures? You have to look at too much water. You have to look at too little water, and really build your infrastructure or change your infrastructure in such a way that you can cope with these kind of issues.
Rick, people are talking about climate mitigation and climate adaptation. Can you explain these terms and relate them to the urban environment, the cities?
Now, as I said earlier, the problem started 150 years ago with the beginning of the Industrial Revolution. So we are already seeing climate change, we're already observing the impacts, and we have to cope with these impacts. And coping with impacts is very much adaptation. So if a city changes sewage system to actually deal with much higher water availability after a big shower, that is adaptation. If a city in a delta changes the dikes, that's adaptation. You really look at predicted impacts and deal with this. Mitigation is taking away the cause of the problem. So mitigation is very much reducing the emissions so that the concentrations in the atmosphere of greenhouse gases are stabilized, and the climate or the anthropogenic climate change does not continue anymore. And if we want to do successful mitigation, so that's stabilizing the concentration, we have to reduce the greenhouse gas emissions by about 80–90% in the coming 50 years.
Rick, we have to reduce these greenhouse gas emissions, and especially in the urban environment, the cities, we have to accomplish this. Can you explain how we can do that?
Now, I think cities are extremely important to cope with this problem because of 2 reasons. If you look at the international negotiations on the Convention of Climate Change, it goes very, very slow. It's very difficult for all heads of states to actually reach an agreement. And I think that the cities, which are local units with visionary mayors, actually can make a difference and be an example of becoming carbon neutral. Second, cities are very concentrated areas which use a lot of energy, where there's a lot of activity, but those can also be made relatively much more efficient. Think about transport. If you do that in a rural area, distances are big. In a city, they're relatively small. So you can use electric cars, electric small trucks, etc., and really embed that with smart grid into the whole infrastructure. Same if you want to cope with some of the impacts. It's that density in the city that you actually can improve the efficiency of a lot of activities. And the cities are impacted. People see it, but people also take the actions. And therefore I think the people in cities are much more willing to deal with this problem than people in rural areas. And the cities, as we've seen in the US, in Europe, are really taking a lead in dealing with this problem.
Yeah, so we learn to think global, and now we have to act local.
Exactly.
Especially in the urban environment.
Especially because about 60-70% of the people live in urban environments.